Hello guys, this is Sushant and welcome to your channel which is SciEngineers. We have been uploading videos for the Mhtcet section for the mathematics for the year 2020 and we have already started with the topic of definite integration and this is going to be the second part to it. Those who are new to the channel, you can go and watch the earlier video for definite integration, and in the playlist for Mhtcet we have over 50 plus videos in it. To help us make more videos for you guys, please do like our videos, do share our videos, and please do subscribe to our channel. To never miss a notification from us, you can just hit the bell icon which besides the subscribe button. Also, stay safe in the current scenario. So let's get going. So as you know that we have started with the new segment wherein we ask a set of questions in the previous video and then we give the solution in the new videos which we are uploading. So these are the solutions for the previous video. So we have the question which was asked, which was minus 1 to 2 the integration for mod x cube dx. So concentrating on the function mod x, as we had discussed in the previous video, mod x is having the value as x which is x greater than 0 and it is minus x for x less than 0. So we know that the limits are going from minus 1 to 2. That means there should be a split at 0. So the integration will go from minus 1 to 0, and since it is in the negative region, so negative region is nothing but minus x. So it is minus x cube which is to be found out, plus it is going from 0 to 2, and since we are from 0 to 2 which is a positive region, it will have the value x. So it remains x cube. So now we know that minus x the whole cube is nothing but minus x cube only, and I need to find the integration for that. So the integration is going to be nothing but minus outside, it's going to be x raised to 4 by 4 going from minus 1 to 0, plus it is going to be x raised to 4 by 4 going from 0 to 2. So if I substitute the upper limit, it's going to be 0. The lower limit with a negative sign, it's going to be 1 by 4. In this case, it's going to be 2 raised to 4 by 4, or plus sign between that. So 2 raised to 4 by 4, it gets cancelled, and this is nothing but minus 1 by 4 plus 4. So it is 4 minus 1 by 4. So we forgot about the minus sign. So this minus makes this as plus. So it's 4 plus 1 by 4. So that becomes 17 by 4. So that's why answer is B. Moving on to the next one, we have x minus the greatest integer function of x, and I need to find the integration for this function from minus 1 to 1. So here the concern is for the range which is minus 1 to 1. So as we had discussed, the greatest integer function is like a step function. It goes one step at a time. So we are talking from minus 1 to 0. So we know that from minus 1 to 0 it will have the value minus 1, and for the range of 0 to 1 it will have the value 0. That is, we are talking about the x value here. So if my x is between minus 1 and 0, it's minus 1, and if it is between 0 and 1, it is 0. So coming down to the question, so we have integration minus 1 for x dx, and minus, it's the greatest integer function. So it is minus greatest integer function. So for greatest integer function we need to split the limit, and the limit will go from minus 1 to 0 with the value of minus 1, and it will go from 0 to 1 with the value of 0. So we need not bother about this because it's anyway 0. So the minus goes outside and it becomes plus. So here we need to find the integration of x, which is x square by 2 with minus 1 to 1, plus this integration is going to be nothing but our x, which goes from minus 1 to 0. So if I substitute 1, it's going to be 1 by 2, and if I substitute minus 1, it's going to be minus 1 by 2. So that's answer 0. Here it's going to be 0 substituted, the upper limit, and minus the lower limit, which is minus 1. So answer is 1. So that's nothing but option A. So we'll be seeing the first two questions which are going to be dependent on the definition of definite integration. So just recollecting the definition of definite integration or the formula for it. So it is going to be limit, that is if I want to find the integration of the function f of x with the limit a to b dx, then that will be equal to, in terms of the summation, so limit n tends to infinity summation f of xi into b minus a divided by n, and here my I is going from 1 to n. So this is the basic definition. So let us just observe the given first question. So we have the limit n tends to infinity, so you can see that the first part, that is the outside part, limit is there, and instead of summation they have given the terms as direct additions of term, and these terms are basically going to be in infinite form. So we have 1 upon root of 4n square minus 1 plus 1 upon 4n square minus 2 and so on. Now let us just try to understand what the term is inside. So we have a function f of x. So this f of xi is nothing but related to this particular function which was there inside the integration. So what we need to do is, the RHS is given, I need to find what is going to be LHS, because we can then easily find the integration directly. So we have to just find what is a function, and for that we have to see what are the terms which are given in. So we have outside this function a b minus a divided by n, which is going to be a common part with this summation sign. So here we need a 1 by n basically to be brought outside this particular summation. So what we will do is, we'll be taking n from each and every term and bringing it outside. So if I'm bringing n outside, it's basically going to be n square which is brought outside. So I'm bringing n square outside, and this becomes 1 upon root of 4 minus 1 by n square. In the same way, it is going to be root of 4 minus 2 by n the whole square plus so on 1 upon. So this 3n square, I am writing it as 4n square plus n square, so minus n square. So this will be written as 4 minus n by n the whole square, and I will be having the 1 by n outside. So now let us just try to relate it. So I have my 1 by n, I need a b minus a, so I need the limits also, so that I have to substitute on the LHS part, and I need the function also. Now from the term itself you can see that basically we have f of xi. Now xi is a term basically which is a point which is to be considered, which is going to be incrementing along the x direction. So xi can be visualized as, it is going to be starting with the first value as a, and then it is going to be going on increasing as it goes ahead. So it's going to be plus I, the incremental value, which is b minus a by n. So it will be of this particular form. Now if I just observe the first term, we have a 4 minus 1 by n square, so which I can write it as 1 by n the whole square. So this 1 by n, so basically my first term is going to be something of the form a plus I b minus a by n, where I is going to be starting from 1 to n. So here my I, this is related to 1 by n, so this n is there, and I don't have an a term, so basically my a should be 0, because inside this bracket I don't have that a term. So a is 0. Now here what you can see is it is going 1, so b minus a is basically 1, that means my b should be 1. So that is how basically you're relating it with the definition. So this entire thing is equal to integration. So we have got the limit, so it is going from a, which is 0, to b, which is 1, and now I need to find the function. So the function is going to be nothing but, you can see the commonality which is present, that is 1 upon root of 4 minus, so this is where the x is basically being substituted, because this is changing. So that is nothing but my x. So whatever is changing is going to be my x, because that is nothing but the xi is basically changing. So the integration is nothing but of 4 minus x square dx. So this is what the integration I need to find. So this thing is nothing but this. So just finding this integration, so you can see that the 4 can be written as 2 square. So it is becoming 1 upon a square minus x square. So 1 upon a square minus x square is nothing but sine inverse x by a. So x by 2. And the limit is 0 to 1. So now if I substitute 1, so we know that's nothing but pi by 6. And if I substitute 0, it's nothing but 0. So the answer is pi by 6. That's nothing but your option D. Moving ahead with the same concept, the second one. So in the second one also we have 1 raised to p plus 2 raised to p plus 3 raised to p and so on. And this whole thing is divided by n raised to p plus 1. So whenever such type of question comes, the first thing what you do is you need to bring out this 1 by n term. So you obviously we can bring that 1 by n term from here itself. So that is why what we are just going to be doing is rearranging it. And I will be splitting it also. So it's basically 1 by n the whole raised to p, because I have removed 1 n from here. So 1 n is going to go out, remaining is going to be n raised to p. So 1 by n raised to p plus 2 by n raised to p, so on, it's n by n raised to p, this whole thing, and we have 1 by n. So again, using the same concept which we used here, I need to find the integration's limit and the function. So it's starting from 1. So this first term is 1 basically. So that means my I is basically starting from 1. So my A should be 0. So my A is 0. That's the lower limit is 0. And it is going till n. So that means basically the last limit is 1. So it's going to be going from 0 to 1 because of this particular concept which we just did in the previous sum. So it's 0 to 1. Now going for the function. So it is 1 by n. So this thing is basically changing. So that means this thing is my x. So it's x raised to p. And the integration of x raised to p, which is quite simple, that is x raised to p plus 1 upon p plus 1 with the limit substitution. And the limit substituted, I will be getting 1 upon p plus 1. So you can see basically you have to just understand what the type of sum is, how you bring it down to the standard form, and once you bring it down to the standard form, the integration is quite easy. It's basically dependent on your standard integration formulas. So the option for this is A. Moving ahead to the third one, we have if 2f of x minus 3f by 1 by x is equal to x, then I need to find the integration of the function f of x, which is unknown to us right now. So it's limit 1 to 2 f of x dx, which is needed to be found. So what we need to do is we need to first of all find some way or the other, we need to find the f of x. So f of x, let's see, let's just take the equation which is given. So 2f of x minus 3 f of 1 by x is equal to x. This is what is given. Now it's basically like I have two unknowns, which is f of x and f of 1 by x. I need one more equation to solve. So that one more equation, basically what we will do is we will replace x by 1 by x. So this becomes 2f of 1 by x minus 3f of x is equal to 1 by x. So I need to get now rid of the f of 1 by x because that is not what is required. So what we can do is I will be multiplying this by 2, this equation by 2, and I will be multiplying this equation by 3. So if I am multiplying this by 2, I will be getting this as 4f of x, and this is going to be minus 6f of 1 by x, and on that side I will be getting this as 2x, and I am basically going to be adding it with this, because this also becomes 6f of 1 by x, which gets cancelled out with it, and minus 9f of x and plus 3 by x. Now if I do the calculation, I will be getting f of x is equal to because this becomes minus 5, that goes that side, so it becomes minus 2 by 5x plus 3 minus 3 by 5x. So I need to find the integration, so integration on both sides. So integration of this is nothing but going to be minus 2 by 5. We know this is x square by 2 minus 3 by 5 log x. So the limits now is needed to be substituted, so we just simplify it a little bit. If I substitute 2, this is going to be nothing but 4 minus 4 by 5 minus 3 by 5 log 2, and if I substitute 1, it's going to be, since it is a lower limit, it's going to be nothing but plus 1 by 5. So if I just do plus 1 by 5, this becomes minus 3 by 5, and if I substitute 1 in this is going to be nothing but 0. So we can see that I can remove minus 3 by 5 common, you can see it over here, and I will be getting 1 plus log 2. So answer is B. So moving ahead to the next one, we have the integration limits as e raised to minus 1 to e, and the integral is of dt upon t into 1 plus t. I need to find this particular integration. So from the type of sum, you can understand that this is basically of the type of partial fractions. So just recollecting what partial fractions are. So I have two terms and I need to split it up. So it's basically going to be in this form, that is a upon t and b upon 1 plus t. So I need to find a. Now to find a, we can use a direct method. The direct method or the formula is whatever is below a, I'll just not multiply it, and whatever is on the LHS, I'll be just multiplying that. And the substitution should be done in such a way that the denominator is going to be 0 for this. So if I just substitute e is 0, this denominator will be 0. So I'll be getting the answer for a as 1. Similarly, using the same concept, whatever is below b, so that is 1 plus t, whatever is on the LHS, those two are going to be multiplied, and the substitution is whatever makes this 0. So this gets cancelled out. If I substitute, I get b as minus 1. So my integration, that is e raised to minus 1 e, instead of this it's going to be 1 upon t because a is 1 and b is minus, so minus 1 upon 1 plus t. So we know that the integration for this is nothing but log t minus log of 1 plus t, and the limit e raised to minus 1 to e. I'll be just writing this as log of t upon 1 plus t. So I will be substituting in this, so it becomes log e upon 1 plus e. Substituting in this, it's going to be e raised to minus 1, so minus, because it's the lower limit, minus log e raised to minus 1 upon 1 plus e raised to minus 1. So this is what we are getting. Now simplifying this, so just writing it over here, it's log e upon 1 plus e minus, I'm writing this because e raised to minus 1 is 1 by e, so it's basically going to be multiplied. So multiplying the numerator and denominator by e, so I'll be getting 1 upon 1 plus e. So I'm getting log e upon 1 plus e minus log 1 upon 1 plus e. So this 1 plus e basically gets cancelled out using the log property basically, and I will be having with the answer as log e, and log e is nothing but 1. So that's your answer. So moving on to the next one, we have the integral which is from 0 to pi by 2 sine raised to 5x dx, and also along with this question we are going to be discussing the sixth also, which is also from 0 to pi by 2 sine raised to 8x dx. So the only difference between both of them is basically the degree. You can see that this is odd degree, and this one is nothing but the even degree. Now these type of questions are very popular, they can be asked, and there is a direct formula. Now whenever you are applying these formulas, there are few things which you have to understand. First thing is that the limit should be always 0 to pi by 2. There is no other way in which we can apply it. So always we need it is to be 0 to pi by 2, and inside the integration we can have a sine term or a cos term. So it can be sine raised to 8x or it can be cos raised to 8x, any of those combinations. Now the formulas are basically divided into two parts. First one is for the even, like if the degree is even in this case, then it is going to be a particular set of formula, and if it is odd, then it is going to be having a different set of formula. So let's first see for the even one. So if I have the degree as even, then the formula for that is given in this format. Let us say that it is sine raised to n and n is an even term. So the formula is half n minus 1 by 2 into n minus 3 by 2 into, it goes on and it ends at half pi. So the last term in this series should be half. If you are getting half, then that's the end of it, divided by, it is going to be n by 2 factorial. So it is n by 2, you calculate n by 2 and then you find the factorial for it. So that's the formula for the even one. So if the degree is odd, then the formula goes as follows. It is n minus 1 by 2 factorial. So it's a factorial of n minus 1 by 2, and in the denominator I'll be having the term as n by 2 into n minus 2 by 2 into n minus 4 by 2 into so on, it goes till 3 by 2. So the end term over here is 3 by 2 and the end term over here is half. Now let us just apply the formula. So since we have this degree as 5, which is odd number, we go over here, we have substitution as 5 minus 1. So 5 minus 1 is 4, 4 by 2 is 2. So we have 2 factorial divided by, in the denominator, we have the term as 5 by 2 into 3 by 2. So that's the end of it. So 2 factorial, we know it's 2. This 2 goes up, this goes up. So it becomes 8 divided by 5 3s are 15. So 8 by 15 is the answer for that. So that's nothing but option B. Moving to the next one. Since the degree is even, the even formula is this thing. So just applying it. So we have the formula as half. N is nothing but 8. So substituting. So that becomes 7 by 2 into, next is 8 minus 3. So that becomes 5 by 2 into, next term is 3 by 2. So you can see it's basically, we are subtracting the numerator over here by 2 every time. So if I subtract one more time, it's going to be half. So that's the end term. So we stop it over here and we multiply with pi divided by n by 2. So that's 8 by 2. So that's nothing but 4 factorial. Now in the options, you can see 4 factorial is not integrated, or basically it's not taken with the numbers. So we keep this term as it is and we multiply the rest of it. So we have 7 5s are 35, 35 into 3, which comes as 105 pi. So basically divided by, we have these 4 2's, basically that becomes 32. And we have this 4 factorial. So you can see it's nothing but option A. Moving on to the last one. So we have question number 7, which is integration 0 to pi, and the summation is given for r is equal to 0 to 3 for a r cos raised to r 3 minus rx and sin raised to rx dx. In this particular sum, they are just asking us on what terms will the integration be dependent on. So basically what we need to do is, just let us try to expand this particular summation because it's not quite clear what they are asking us. So let us just expand this summation. So it's just substituting the values. R is basically going to be substituted first as 0. So it becomes a0 cos cube x. Next term is going to be, if I substitute the next value, which is for r is equal to 1. So it becomes a1 cos square x sin x plus a2. The next term is nothing but cos x sine square x, and the last one, which is for r is equal to 3, it's a3 sine cube x. So this is basically the integration which is asked. Now we have to just see on which term will the value of integration depend on. Now basically what they are trying to understand, or basically what they want, is you need to apply a particular property over here. So what is that property which is to be applied? The property is as follows. If I have 0 to 2a f of x dx, now this particular integration, we know it can be split up into two parts. The two parts are basically 0 to a f of x dx. So we are just taking half of this, plus it is going to go from 0 to a f of 2a minus x dx. Now in this particular sum, if I have f of 2a minus x dx, if it becomes f of minus f of x, then this two integration will cancel out each other. And if my f of 2a minus x basically becomes f of x, then it will be just addition of these two terms. That's basically the property which we have to use. Now that all depends on my f of 2a minus x, whether the term is going to be f of x or whether it is going to be minus f of x. So here let's concentrate on the first one. We have a cos cube x. So here my 2a is nothing but pi. So if I just do cos of pi minus x, so I know cos of pi minus x is minus cos x, and it is raised to 3. So that is going to be making it as minus cos cube x. So that means if I just apply this property, this term is anyway going to be cancelled out because it's going to be 0. So this term gets cancelled out using this property or this logic. Moving on to the next one, we have a cos square x sin x term. So again applying the same thing, that is instead of x I am applying pi minus x. So cos of pi minus x, as I know, it's minus cos x, but it is squared, so that means it becomes plus cos x, and sine of pi minus x is still sin x. So this term remains because my f of 2a minus x becomes f of x. So it will depend on a1. So that's the first thing we understand. Moving on to the next one, cos x sin square x. So using the same logic, cos x becomes minus cos x, sin square x remains sin square x, but since we are having the minus because of the cos x, this term will cancel out, and sin cube x remains. So you can see this term gets cancelled out and a3 or the sine cube term remains. So because of that, the integration depends on the value of a1 and a3. So that's your option D. So as you know, we have started with this new segment wherein we ask you a set of questions and you can just post your answers in the comment section. So these are the two questions for this particular video, wherein they are asking us the integration for sine of 1 by x upon x square dx, and the limit is 1 by pi to 2 by pi. And the next one is that if this integration is equal to k log 2, then what should be the value of k? So just let us know in the comment section what the answer should be for this particular question. So thank you guys for watching our videos. Please do let us know in the comment section how do you find these videos, whether it is helping you in your preparation or not. Do let us know in the comment section what more videos you would like us to make on. If you are new to the channel, you can just see our playlist for Mhtcet, which has over 50 plus videos related to different topics of mathematics. So do like our videos, do share our videos with your friends, and do subscribe to our channel. To never miss a notification, hit the bell icon. This will help us make more videos for you and inspires us to do so in the future also. Also do stay safe in the current scenario. So keep learning, keep watching, and happy learning. Bye.